Hi, this is Jessica Ackerman here with Module 2 Critical Review on Meaningful Learning and Schema Theory, Cognitive Information Processing, and Self-Regulated Learning. The Meaningful Learning and Schema Theory was developed by a theorist named David Ausubel. The theories are all about making connections. It's how we relate new knowledge or learning to what we already know. The learner's background knowledge is considered their schema. This is what a learner already knows and how one uses this schema to make connections to the new learning. Cognitive information processing is a theory on how information is processed and moved from sensory to working to long-term memory. Self-regulated learning is where learners set academic or behavioral goals and monitor their progress along the way in order to increase cognition. Now, why the need for further review? All these theories have proven effective. One thought on the theories in general is that these strategies of processing information, motivating learners, and supporting retention are all effective for the majority of the learners or the average learner. However, further review should consider the many differences in learners, such as their strengths and weaknesses in learning styles or mental capabilities. These most certainly affect a learner's processing. Additionally, educators should use these theories to review strategies to support learning in the classroom. When students may lack much of the background knowledge that's needed and the schema that's needed in the information to make the connections to the new learning. Also, educators need to study ways to directly teach metacognition and goal-setting strategies to support students and being more self-directed, since that, to me, is the end goal of education, is teaching students to learn to teach themselves and to monitor their own behavior. My personal evaluation, reading through the chapters in this module 2, I was able to make many personal connections of how these theories are used in education every day and how I've seen them to be successful. Many of the strategies within these theories are also built into research-based assessments that are used in many school districts and also in the T-TEST teacher evaluation system created by the state of Texas that us administration uses for teachers to observe them and evaluate them. I believe these theories are valuable and all teachers should study them and apply these techniques and strategies in the classroom. The meaningful learning theory and schema theory, as mentioned before, was by David Ausubel, and he was the lead theorist of the meaningful learning theory. Ausubel's intended purpose of this theory was to provide appropriate ways to frame learning in order for learners to not only pay attention to what matters, but also to scaffold the learning in such a way that new learning builds on top of and off of prior knowledge. In Ausubel's learning theory, direct teach or reception learning versus discovery learning is discussed. Direct teach is unfortunately what we see many times in the classroom still today. This is the sit and get type teaching where the teacher lectures in front of a class of learners who sit and listen. On the opposite end of the spectrum, there's discovery learning, where learning is an event. It's motivational and it's memorable. Students are actively engaged instead of just sitting and listening. One example of an application of this is a math introductory lesson on the order of operations. A problem was written on the board and students were asked to solve without any prior instructions. The students with the correct answers were able to explain what process they took to the rest of the class to solve the problem. This happened several times before the students finally realized using the process of elimination experimentation, they discovered the correct order of operations. This was exciting problem-solving discovery lesson, and it's going to stick with the students much longer than just the teacher giving them the information and telling them the order. What order to solve the problem will stick longer because they figured it out themselves. It was an event. Ausubel states that 3 conditions need to be present in order for meaningful learning to take place. First, the learner's intentions. A learner must choose to actively be engaged. In the order of operations lesson, the student could very easily choose to just doodle or pretend to solve the problem until the classmates found the solution. In this case, the learner is choosing to just memorize the information. This is called rote learning. In this case, the student learning will not be have as deep of an understanding. And secondly, the information must be meaningful to the learner. This is where teachers need to make real-world connections and future learning expectations known so that there's a purpose for learning the new material and the students want to be actively engaged. Lastly, the learner must have some sort of prior knowledge or schema to anchor the new information to. This is referred to as the learner's cognitive structure. Driscoll states that the most important single influencing learning is what the learner already knows. New learning is filed away in the brain during a process called subsumption. Derivative subsumption is when a new idea is filed under an already familiar topic or idea and supports or adds to that idea. Correlative subsumption is when the new information changes what the learner already knows in some way, like the order of operations, for example. The learner already knows how to add, subtract, multiply, and divide. However, up until this point, the learner was not aware that the order in which they do those things were important and could actually change the answer or the result. When these conditions are in place, then meaningful learning takes place, and then retention is supported, and learners are less likely to forget the new information. The schema theory complements meaningful learning very well. Driscoll states, learners comprehend and remember information better when they can relate it to a familiar theme. That familiar theme is a person's schema. This schema can be triggered when learning new information that can connect to the familiar theme. For example, in a second grade classroom, I recently listened to a read aloud of The Three Little Cajun Pigs. Students had prior knowledge or schema from the original story of the Three Little Pigs that we're all familiar with. Students were able to make predictions, analyze the story, make inferences, and understand unknown vocabulary words due to the schema that the students could already pull from the original story. If the students had never heard the original story of the Three Little Pigs, the Three Little Cajun Pigs would have been a little bit more confusing, and they wouldn't have been able to understand it and draw those conclusions as easily. Schema is added to, changed, or built upon in three different ways. Accretion is by fact learning, simply new information added to one's cognitive structure, like, let's say, horseback riding. If that's completely new to me, that would be accretion. But then tuning is when the information is added that refines what somebody already knows. This could be where, after learning horseback riding, I could tune that theme or the information that I already know with learning to do barrel racing or trick riding. Restructuring is when schema is replaced completely or restructured. My first thought on this was a child's learning that Santa isn't real. Their schemata around the Christmas theme then completely changes from what they already knew. Moving on to cognitive information processing. This is the theory of how new information is processed through a learner's cognitive framework and how far it must go and what must happen for that new information to get to a learner's long-term memory, which would be the end goal. Driscoll explains it well by stating that stimuli became inputs, behavior became outputs, and what happened in between was conceived of as information processing. The first stage of cognitive information processing is sensory memory. This part of our memory only holds information briefly. Sperling did an experiment on sensory memory that determined the brain can only process so much information at this stage, but when attention is focused at one area of the brain, can recall the facts easier. This is why being explicit when you're teaching and starting a lesson with an objective for the students is very important. It tells the student what's most important to focus on, what they're to expect to learn, or example, in Module 1 of this course, you gave us an outline for our notes to use while we read. This focused our attention on what was important. It helped me a lot to focus my instruction on what really mattered. Automaticity is also mentioned in this section by Driscoll. This reminded me of students learning their math facts. When solving a word problem, students should already be able to solve simple math equations with automaticity. So this is by practicing it over and over again. It becomes so automatic to them that they don't have to think about it. They just know it. This way they can save the problem-solving part of the word problem to the actual comprehension of the math problem without worrying about the actual facts. The next stage is the working memory, or also called the short-term memory. Driscoll states a learner can work with 7 plus or minus 2 things at a time, or better yet, called multitasking. One strategy mentioned in Driscoll's book was chunking. This is where information is broken down into easier, more manageable pieces for the learner and can then be built upon. The strategy is actually used in our SPED department and our 504 paperwork and our IEPs for students at our school as a classroom accommodation. Students are able to retain information better if it's broken down into pieces and it's more manageable for them. Working memory will only work to retain information if rehearsal and encoding take place. Rehearsal is simply the idea that practice makes perfect. This is why students have guided and independent practice in the classroom. Also, why students have homework of what they've already learned. The more times you do it, the better the chance of retention. Driscoll mentions that during a 50-minute lecture, learners will most likely only remember the first 10 and the last 10 minutes, and that's it. As a school, we actually studied this a few years ago, and we implemented what we called a turn and talk program, where we encouraged teachers to give short bits of information to keep the attention of students, and then have the students turn and talk to a friend about what they've just learned. This strategy supports retention, and this way they remember what you've taught because there wasn't such a long input part of the lesson. Sit and get. Rehearsal alone doesn't ensure information goes into the long-term memory. Encoding must take place as well. This is again where new information needs prior knowledge to anchor to. Two strategies suggested are mnemonic devices and imagery or visuals. A mnemonic device I've seen used is GEMS, G-E-M-S, to help students remember the steps to solve the order of operations problem. When you actually solve the problem of order of operations, it gets smaller. It starts long at the top and gets smaller at the bottom and ends up looking like the shape of a gem. This is something that the learner will remember, and they discover it on their own, and they'll remember the steps to the problem. So it also helps self-regulate them. Metacognition is another important strategy that must be directly taught to students to help them to do it on their own. Students should learn to ask analytical questions to themselves to spur their thinking. This can be modeled aloud by teachers. And again, this is another self-regulation skill. Last but not least is your long-term memory. There are two parts, episodic and semantic. Episodic is when a person remembers the event that led them to learn a certain thing. For example, the order of operations discovery activity. That's likely to be remembered in order to trigger how to solve a similar problem. Semantic memory is whenever a person just knows how to do something, but they can't really remember the actual learning of it. Teaching strategies to encourage new learning to go through all of the stages and into the long-term memory would be to have explicit objectives that the students read together and revisit throughout the entire lesson to stay focused on what's important. Also, organize lesson structures, keeping in mind individual background knowledge and to build on that background knowledge, and to also model metacognitive thinking and the use of visuals to trigger their schema. Moving into self-regulation. Self-regulation is the last, and in my opinion, one of the most important theories. It's what I look for in each classroom when doing teacher observations. And the teacher actually teaching the students how to become responsible for their own learning and relying less and less on the teacher. I've personally seen where students set a goal for their benchmark tests, monitor their progress by recording grades on a bar graph, and then students then plan with the teacher what can be done to improve after each benchmark test. This is an example of the ARCS process, A-R-C-S, in the Driscoll book. First, the teacher must gain the student's attention. This can be done in many ways, like surprises, humor, curiosity. The teacher I mentioned earlier gained the student's attention with an extrinsic motivator, since it's hard to get students too excited about a long multiple choice test. The students were working towards a longer recess if they met their goal. Next is relevance, or why is it important to the learner? In this case, the benchmarks prepare students for state testing, which has a lot to do with passing or failing in 5th grade.